I'm Saritha Kumari, Assistant Professor EEE Department, working at Institute of Aeronautical Engineering College, Dundigal, Hyderabad. Today the topic is voltage distribution over a string. So this is again the topic mapped to course outcome 2. So methods of improving the string efficiency. So we know that there is a type of insulator which is a suspension type insulator. In my last lecture we have seen. Okay, so there are 4 types of insulators. Out of that, commonly used one is a second type, that is suspension type insulator. So suspension type insulator means, so in the name itself it is there are number of units, number of porcelain discs are connected in series by metal links to form a string. So here we know that in that there is a non-uniform voltage distribution over that string. Okay, so here the bottom unit that is near to the conductor, the bottom unit, let us say there are 3 units. Okay, so we know that, so this is a bottom unit, last one, right? So this is one, okay, unit 1, first one, this is 1, and voltage that one across that one is V1, okay, and V2, and this is V3. So right, so the total voltage is divided, if there are 3 units, that is how the voltage is distributed. And this voltage distribution is distribution not uniform. So here what happens is, generally the unit, the porcelain disc that is near to the conductor, this is a conductor, right, and this is a cross arm. Okay, so the unit near to the conductor that experiences maximum voltage across that, and as we move away from the conductor, the voltage across the units becomes less. Okay, so the unit that is near to the conductor, that experiences a maximum voltage drop across that, and as we move away from that, the voltage drops across the units goes on decreasing. So the unit near to the conductor experience a maximum stress, maximum electrical stress, and also mechanical stress. So because of this, what happens is, if there is a damage of the unit, this bottom unit occurs, suppose, then successively the remaining units also gets damaged. That is a possibility. So what they want to do is, they want to get the uniform voltage distribution. Okay, they want to get the uniform voltage distribution across the units, all the units of the string. So for that, they introduced this methods of improving the voltage distribution. That means improving the string efficiency. Okay, that is nothing but, we know how the efficiency is defined, right? Efficiency defined voltage drop across the total voltage by number of units into voltage of across the near unit that is near to the conductor. So now under this, they have given, there are 3 methods. They have first one, by using longer cross arms. Okay, that is the first one, and then second one, grading the insulators, are that is also called capacitance grading, and third one, by using a guard ring, that is nothing but they also call it as static shielding. So we see one by one. So by using first method, by using longer cross arms, you can see on the right side there is a diagram which has the 4 units. Okay, the string has 1, 2, 3, 4 units. The string has, and at the down this is a conductor, right? And on the top we see that this is the cross arm. Okay, from there the string is suspended. Okay, on the down the conductor is passed to the through the insulator. Next, on the side there is a tower support, right? Transmission support, transmission line support. So now we know that if this is a string like this, okay, between the each metal link and the pole supporting tower, there is a shunt capacitance form comes into the picture, right? So this is what's shown. Now see that by using the method is they are telling longer cross arm. Use the longer cross arm. So what happens if we use the longer cross arm? Basically, because of this shunt capacitance, uh, we have a relation, right? Relation between shunt capacitance and self capacitance. What is self capacitance? Each unit, okay, is each porcelain disc is replaced with a capacitance, can be considered as a capacitance, which is called self capacitance. Okay, now so they're telling, okay, and we know that this C1 shunt capacitance is a fraction of the self capacitance. So based on that, we have a ratio between this C1 and C as like this. Okay, so C1 is a fraction of the C. Okay, now if we use a longer cross arm, what happens is the distance between the tower and the string goes on more. Automatically, this shunt capacitance effect can be neglected, can be eliminated. Okay, if we use if we increase the length of the cross arm between the tower, okay, this one, okay, if we increase this length, what happens? The capacitance effect, the shunt capacitance effect can be neglected. Okay, because the distance is more. So that's why K C1 effect can be neglected. C1 can be neglected means automatically K ratio will be reduced. K value will be reduced. Automatically, what happens is we have in the circuit only self capacitance, because we know that all units are the same type of the same rating. Okay, so automatically same current flows through the each unit and same voltage appears across the each unit. Okay, so because of that, finally the efficiency can be improved. Efficiency eta can be improved. So that is how the first method, using longer cross arms, okay, the efficiency can be, that means uniform voltage distribution there is a, and finally efficiency can be improved. So that is a, this is a point. Okay, uh, whatever I explained, so this is mentioned here. But there is a one limitation also here. We can't increase the length of the cross arm so much, because that may increase the cost, right? That may increase the cost. So there is a limitation on the cost. Okay, because of the limitation, there is a limitation because of cost, and also strength of the tower do not allow using very long cross arm. And in practice, K is equal to 0.1 is a limit. Okay, so that is a value, minimum value we can go for. Second method, by grading the insulators or capacitance grading. So here you can see, okay, the what they do is grading the insulators. In this method, they use porcelain discs of different dimensions. They use this units of different dimensions. So each unit has a different value of capacitance. Different value of capacitance. So that's why it is shown as, okay, the top unit has self capacitance C1, next to C2, next to C3. That is how they have shown. Now, um, so here, which capacitance is the where the capacitance has the highest value? Okay, see that here we see that C1 is the top unit capacitance, C3 is the bottom unit. Now, and also we know that basically the bottom unit, okay, this unit has the maximum voltage drop across that. Okay, so the maximum voltage drop across the bottom unit, okay, is nothing but we can use a highest capacitance at the bottom, because the voltage is inversely proportional to the capacitive reactance, right? So that's why, that is how, right? Okay, so is directly proportional to the capacitive reactance, right? So the voltage is inversely, okay, is directly proportional, inversely proportional to the capacitive reactance. So we have to use, uh, so because it experiences maximum voltage, okay, we have to use a, we have to use a um, maximum value here only. I'm sorry, this is, okay, we have to talk in terms of C, right? Okay, V by XC means, V by XC means V into omega C, right? So nothing but, so we have to use maximum voltage drop here means, maximum voltage across this unit means we have to use the maximum value of the C3, okay, capacitance here. Then what about that? Next, this capacitance, okay, go on decrease as we move towards the cross arm. Okay, so that's why it is shown that the bottom unit capacitance is greater than the top unit capacitance. Okay, so that is how they use a different dimensions of the units. Okay, so that they will get the different values of capacitances, self capacitances. Okay, so based on that we can get the uniform voltage distribution. So that is what it is mentioned here. Okay, but disadvantage here is large number of, we need to have the large number of different sized insulators. Okay, so that is one disadvantage. Next, third method, using guard ring. Using guard ring, that is nothing but a metallic ring. A metallic ring. Okay, guard ring means they are using a metallic ring, okay, around the conductor. They are using a metallic ring around the conductor. So because of that, what happens is it introduces a new capacitance. Okay, it introduces a new capacitance between that metallic ring and each metal link. Okay, so we know that these are the metal link points, right? So this introduce new capacitances, okay, in the system between that metal ring and the metallic ring. So here you see in this system, 3 unit system, okay, we have this, okay, new additional capacitances. Here see that, so because of this there is a new capacitance, there is a new current flows into the system. Okay, so whatever the current flowing away from the this metallic ring, okay, is given I2, small I2, which is equal and opposite to the current in that new capacitance part. That is, if that is small I2, it is I2 dash. So it is equivalent but opposite in direction. Similarly, here also the current in this is I1 dash, okay, which is equal to I1, small I1, but opposite in direction. So this new capacitances are C2 and C3. Okay, so that is how this guard ring introduces a new capacitance in the system between each metal link and metallic ring. So what happens is this I2 dash, as I mentioned, is equal and opposite to this current I2. So automatically both cancel each other. This C3 effect nullifies the C1 effect. Okay. So this new capacitance C3, okay, cancels the this shunt capacitance effect. Similarly, here also this new capacitance C2 nullify the shunt capacitance C1 value. So that is how this guard ring, okay, guard ring makes the uniform voltage distribution. Finally, we will get the, okay, good efficiency across the string, good efficiency of the string. So this is what the points are mentioned. So finally, just to keep in mind that uh, while solving problem related to string efficiency, first point, the maximum voltage appears across the disk near to the conductor. The maximum voltage, right? We know this point. Maximum voltage appears across the unit that is near to the conductor, that is down one. Next, second point, voltage across the string is equal to the phase voltage. What is the voltage across a string? That is a phase voltage of the system. That means voltage between line and earth. Okay, or phase voltage. Next, third point, line voltage is given by, that is root 3. That is root 3. Okay, root 3 times the voltage across a string. That is nothing but phase voltage. Next, failure of insulators. Okay, next topic, failures of insulator. Okay, there are possibilities for the failures of the insulator. What are the causes? What are the causes for this insulator failure? First one, cracking of insulator, cracking of cracks. Okay, so they are telling that maybe in the main porcelain body. You can see on the right side the how a insulator, basic insulator. Let's say it's a pin type insulator, right? So um, main porcelain body, the crack in the maybe, okay. Uh, then steel fitting, okay, steel fitting. We know that, okay. On the top of the unit, there is a groove, right? There is a groove through which the conductor is passing, okay, and it is attached to the this insulator by using a wire, right? So there is a that means here there is a pin, okay. So here they say that the crack may be in the steel fitting. Then cement to fix the steel part with porcelain. So in all these areas, okay, there is a possibility for cracking. Next, porosity in the insulation materials. Next, third point, defective insulator material. Next, fourth, improper glazing on insulator surface. Okay, on the insulator surface, there is a, okay, glazing. Then they are telling last point. There is a main point, flashover or puncture across insulator. Okay, flashover or puncture. Okay, these are all are the causes, various causes for the insulator failure. Okay, we'll see what is flashover, what is puncture. Okay, so before going to that, they're telling the insulators are required to withstand both mechanical and electrical stresses. The electrical stresses are mainly due to flashover or puncture. Okay, now see that flashover is nothing but flashover is nothing but first, okay, after flashover only puncture comes into picture. So first flashover means it is nothing but it is nothing but the air around the insulator, the air around the insulator breaks down and there is a flashover, okay. There is a flashover that short circuits the body of the insulator, okay. That the flashover, okay, the air around the insulator gets breakdown, right? So and finally the flashover takes place, okay, shorting the insulator, okay. So and here the flashover means that is an arc or discharge, okay, a discharge occurs, so that takes place, okay, and shorting the insulator, okay. That means here this discharge or flashover uh, passes through the distance between the pin conductor and the pin. So here that the flashover passes through distance this A plus B plus C. Okay, you can see this. So that is how the flashover occurs. Okay, this is nothing but the air surrounds the insulator, breaks down and results in a flashover. That means an arc or discharge occurs. Okay, which shorts the insulator, and this passes through the distance between the conductor and the pin, okay. And because when a flashover occurs, generally the insulator will remain continue to work unless the heat generated by this uh, is uh, uh, is exceeded and destroys the insulator, okay. If the heat generated is more because of this flashover, then only the problem will take place, okay. Next, what is this puncture? Next, what is meant by puncture? Puncture means the puncture means the insulator um, gets breakdown. The insulator gets breakdown, and the flash and the current flows through the body of the insulator. Okay, so puncture means, okay, there is a they're telling the it is a okay. If we say in terms of operating voltage, this is how we can define puncture voltage. Anyway, basically, in insulator, puncture means the flashover or discharge. The discharge occurs, okay, arc occurs from the conductor to the pin, okay. So that means here current passes through the body of the insulator itself, okay. So that's why they say it as it at which the insulator breaks down, okay. The insulator breaks down. The discharge, that means the discharge occurs from the conductor to the pin, okay. So here is a conductor, okay. Here is a pin, right? In the diagram you can see. So okay, so that's why the current passes through the body of the through the entire body of the insulator. So there is a puncture takes place. That is how the puncture takes place. But if a puncture takes place, then the insulator gets completely destroyed, okay. That is how it is. So generally, uh, and there is a factor they define, safety factor, in terms of this puncture and flashover. So safety factor is defined as puncture strength to flashover voltage, okay. And this value is generally very high, okay. This safety factor value is generally very high, okay. So so that uh, the puncture takes the flashover can takes place, okay, before the puncture occurs, okay. The flashover will takes place before the puncture occurs. So that is how that is the reason. So for the high value of safety factor, generally the maximum value also it is 10 only, okay. The safety factor maximum value. So this is about the failure of insulator, okay. Failure of insulator that occurs in either a flashover or in the form of flashover or puncture, okay. uh, Next, so these are my references related to this topic. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.